Okay, this is a interval estimation for independent sample, but we focus on case number 3 and number 4. Case number 3 is when the population variance are unknown, but we assume there was unequal, sigma 1 square not equal sigma 2 square, and both cases are less than 30. Okay, since the sample size is less than 30, you should remind that we're gonna use the statistic. Okay, so this is the formula for the confidence interval for the difference between two population mean when we assume variance are unequal. So the formula is given by x bar 1 minus x bar 2 plus minus t alpha over 2 degree of freedom times square root s1 square over n1 plus s2 square over n2, where the formula for degree of freedom df equals to s1 square over n1 plus s2 square over n2 power of 2 over s1 square over n1 power 2 divided by n1 minus 1 plus s2 square over n2 square power of 2 over n2 minus 1. Okay, the formula is quite lengthy, but don't worry, you should calculate the value of df carefully. Okay, and then case number 4, population variance are unknown, but we assume the variance are equal. Again, the number of sample size here is less than 30. Okay, the formula is given by x bar 1 minus x bar 2 plus minus t alpha over 2 degree of freedom n1 plus n2 minus 2 times sp times square root 1 over n1 plus 1 over n2. Okay, where SP here means pool standard deviation. Okay, when we assume the variance are equal, we need to pull the standard deviation, and the formula of SP equals to square root n1 minus 1 s1 square plus n2 minus 1 s2 square over n1 plus n2 minus 2. Okay, let's take a look for case number 3, when we assume the variance of standard deviation are unequal. Okay, look at this example. The following data represent the running time of films produced by two motion picture company. Okay, we have two company, company 1 and company 2, and we are given the value of mean, standard deviation, and sample size for both group. Okay, so the question is, find a 95% confidence interval for the difference in mean running time of film produced by company 1 and company 2. Assume the distribution of time to be approximately normal with unequal variance. Okay, so you can see the hint given here. They said that both population has unequal variance. So what should you do first? You need to find the value of degree of freedom by using the formula df equals to s1 square over n1 plus s2 square over n2 square over s1 square over n1 power of 2 over n1 minus 1 plus s2 square over n2 power of 2 over n2 minus 1. And finally, we get the value of degree of freedom equals to 7.3766. Okay, here you need to truncate the value of df to the lower value of degree of freedom. So degree of freedom equals to 7. And alpha here equals 0.09. So T alpha over 2, degree of freedom 7 equals to 2.365. Okay, by referring to the statistical table number 7. And after that, the 95% confidence interval equals to negative 41.1994, 15.9994. Okay, next question. Can we conclude that the mean running time of film produced by company 2 exceed the mean running time of film produced by company 1 by more than 10 minutes? Explain your answer. Okay, so how to interpret the interval? Okay, since the interval passing through zero value, the mean running time of film produced by company 2 equal to the mean running time of company 1. Okay, look at the interval. It is between negative 41.1994 and 15.9994. So, this interval contain zero value. So, what can we conclude? When we minus mean company 1 minus mean company 2, this will be equals to 0. So this is mean company 1 are equal to mean company 2 because the interval contain the zero value.